Hello everyone, my name is Mohit and I welcome you all to my YouTube channel. This is challenge number 5 of solving DSA challenges playlist, and in this video we will discuss a very important and advanced interview question which was asked in one of the product based company interview. Okay, so let's start our discussion. So this challenge is all about sublist reversal in linked list. So what is this problem statement we will discuss in a bit, but one point we have to make sure that while solving this problem we must maintain the time complexity of order n and space complexity of order 1. So now let us understand this problem statement in detail. Okay, so here you can see we are given linked list. This is the head pointer, and to reduce the complexity of the problem, interviewer has removed tail pointer. And ask is we have to reverse this linked list starting from index 1 to index 4. Okay, so starting from node number 2 to node number 5, we have to reverse this sublist part. And after reversing, the final linked list will look something like this. Okay, so if you see this sublist part starting from index 1 to index 4, the node position has been reversed. Okay, so this should be the final output after implementing the solution. So if we go to next slide, so again let's say this is the linked list given and we have to reverse starting from index 2 to index 4. If we apply our function that we are going to create, it should output something like this. So 1 and 2 would be at same place, and starting from index 2 to index 4, this sublist part will be reversed, and then 6 will be at same place. Okay. Similarly, this is example number 3 where they are asked to reverse the whole list. Why I'm saying whole list? Because start index is 0 and end index is 5. So basically we have to reverse this whole list. Okay. So this is how the final linked list will look like. It will just reverse every node position. So this is what we have to achieve. Now let's implement the logic. And for that, let me switch to Visual Studio Code. Now this is the same part of code that we have been discussing from starting of this playlist. So we have two class node and class singly linked list. Class node is responsible to create a node with its properties, and singly linked list class will initialize few properties like head and length. In this case we have not considered tail as per the requirement, and we also have few method inside this class, print value and append. So print value will basically print all the node value in sequence, and if we want to add any node at the end of linked list, we can use append method. So if you really want to understand this code in detail, I request you to please refer my previous video. I will put that video link in description, and you can also get the link in I button. Okay, so now let us write our logic for sublist reversal in linked list. So I'll name this function as reverse underscore between, then we'll put self keyword, and it will accept two index as an input parameter. One is start index and another is end index. Okay, now what I will do, first I will create a dummy node with value 0, and in order to create a node we can use this node class, this one, right? So if we call this class, it will create a node with value whatever we provide. So we have provided value 0, so it will create node with value 0. And don't worry, I'll explain why am I doing this step. After creating this dummy node, we will connect this with first node. So dummy.next will become self.head. So next pointer of dummy node will point to first node, which is pointed by head pointer. And we will create another pointer previous node, and we will point this to dummy node that we have created just now. So again I'm saying just follow the step which I'm doing here. Very soon you will understand the reason behind it, why am I doing these things. Okay, so first let me write the code and then I'll explain it to you. So once we have created this dummy node and we have pointed this pointer to newly created dummy node, what we will do, we will move this pointer to the node just behind start index node. So let's say start index is 2, means this previous node pointer will point the node which is at index 1. Okay, and you will get the answer of why very soon. So previous node is pointing to the node just before start index node, and we will create another pointer called current node which will point to this start index node. Okay, now again we will create a for loop, and this time we will put range equals end index minus start index. So let's say end index is 4, start index is 2. So this loop will iterate 2 times. So here what we will do, we will actually perform the movement of the node for the reversal part. So first thing is we will pick a node which has to be moved, and we will always keep that node which is next to this current node what we have created. Okay, so again I'm saying you will get the answer of every line once we are done with this coding part, and I'll explain it using slide. So you can visualize and connect the things very easily there. Just try to understand what I'm writing here for now. Okay, so here we will create a pointer which will point to the node which has to be moved, and every time we will move the node which is next to this current node. So we will do current node dot next. So we have sequence of node like previous node which is pointing to the node which is just before start index. Then we have current node which is pointing exactly at start index node, and we have node to move which is inside this for loop, and it will always point the node which is next to this current node. Now once we decide which node to move, then we will interchange the node position. So current node dot next will point to node which is next to node to move, and node to move will point to node which was next to previous node. So for the first iteration it is nothing but current node, and previous node will point to node to move. Okay, so these steps which are inside this for loop will iterate this number of times, and ultimately we will get the required result. Okay, again how it is doing I will explain it in detail, don't worry. Then in the end we just have to ensure that head is pointing to first node. So self dot head will point to first node, and what is first node? The node which is next to dummy node, right? So this is the complete logic of this method for reversing the sublist of linked list based on given start and end index. Okay, now let us discuss this logic in detail, how this is reversing the node. Okay, so now coming to the explanation part. Okay, so to understand this thing, I have considered this linked list where head is pointing to this first node, and we have to reverse this part of this list starting from index 1 to index 3. Okay, so this is the requirement. So based on the method what we have written, let us understand the flow. So first what we have done, we have created a dummy node with value 0, and we have pointed it to first node, which means this dummy node is now connected with first node, which is pointed by self.head. So that's what we have done here. You can see this is the dummy node with value 0, and we have connected this with first node. Okay, so this is about first two step. Now we have created previous node pointer which is pointing to this dummy node in start, and now what I will do, I will create a for loop and move this previous node pointer based on the start index. So in our case start index is 1, so this for loop will iterate one time, right? So previous node will now point to previous node dot next, That means dummy.next, and dummy.next is nothing but first node. So previous node will point to first node. So that's what we have shown here. After for loop, previous node will finally point to this first node, which is just before start index node. Okay. So start index is 1, so previous node will point to index 0. Now we will create a new pointer which is current node pointer, and this pointer will point to next node of previous node pointer. So previous node is currently pointing to node with value 1, so current node pointer will point to this node which is at starting index. So this is previous node pointer and this is current node pointer. Okay, till here it is clear. Now, so we are done with this part of coding. Now coming to this second for loop. So this is the end index and this is the start index. So end index is 3, start index is 1. So just focus on this line. Now this for loop, this second for loop will iterate 2 times. Now let us understand this part of for loop. So there will be 2 iterations for second for loop. So let us first talk about first iteration. So previous node is pointing to first node and current node is pointing to second node. And that we have already seen here, right? Previous node is pointing to first node, current node is pointing to second node, which is at start index. These 2 pointers will not change. Now let's focus on this node to move pointer. So according to our code, during iteration 1, node to move pointer will point to current node dot next. And what is current node? Current node is 2. So 2 dot next is 3. So node to move pointer will become 3. Okay. So that's what we have shown here. Node to move pointer will become 3. Now second line of this for loop is next pointer of current node will point to this part. And what is node to move dot next? This is current node. So 2 dot next means 2 will point to node to move dot next. Node to move pointer is pointing to this node and this node dot next is nothing but node with value 4, right? So current node dot next will point to this node. So 2 will point to 4. This is the meaning of this second line of code. So how it will look like? This 2, which is current node dot next, will point to node number 4, which is node to move dot next, and rest all node after 4 would be same. Okay. Now let's talk about this third line. The node which is pointed by this pointer, that particular node will point to previous node dot next. So if you see linked list, this is the previous node dot next is nothing but our current node. So node to move dot next, which is 3, will point to previous node dot next, which is 2, and after that all the node would be same. And what is this third line? Previous node dot next. Previous node is node with value 1 dot next. So next pointer of node this value 1 will point to node to move pointer. And what is node to move pointer? It is 3. So next pointer of node 1 will point to node 3 and rest all node will be same. Okay. Now if you connect these 3 logic what we have created, and if you try to create new linked list after iteration 1, this is how it will look like. Now dummy node is same, pointing to first node with value 1. Now node with value 1 is pointing to node with value 3, right? So next node would be node with value 3. Now 3 is pointing to node with value 2. So after 3 we will put 2, and here 2 is pointing to node with value 4. So after 2 node 4 will come, and rest of the node would be same. So after that all the node will come which is connected with node 4. So if you see original linked list, after node 4 we have node 5, right? So this 5 will come. So this is new linked list after iteration 1. Okay. Now this for loop will iterate 2 times. So after completion of iteration 1, we have already seen how new linked list will look like. So first is done. Now coming to second iteration. So again we will follow these steps. So first step is node to move will now point to current node dot next. Okay. So this is about iteration 2. So again, previous node and current node we have already calculated. Now here, if you see linked list here, node with value 2 is pointing to 4. Okay, so this node to move pointer will point to current node dot next, which is node with value 4. Now second step is current node, which is 2. So 2 dot next will point to 4 dot next. If you see this first diagram, 2 dot next will point to 4 dot next. And what is 4 dot next? So after iteration 1, 4 dot next is pointing to this node 5, right? So 2 dot next will point to node 5 and rest all node would be same. Now coming to this third line of code, node to move, which is 4. 4 dot next will now point to previous node, which is 1 dot next. Okay, so 4 dot next will point to 1 dot next. And what is 1 dot next? 1 dot next is nothing but 3, node with value 3, right? So node 3 will come and rest all node would be same. Now what is this last line? Previous node dot next. So previous node is 1 dot next will point to 4. So 1 dot next will point to 4, rest all node would be same. Okay, so this is the connection we have created after iteration 2. Now let us join this. So after iteration 2, new linked list will look something like this, where this is dummy node pointing to node with value 1, and here you can see node 1 is pointing to node 4. So node 4, then 4 is pointing to node 3. So after 4 we will have node 3, and 3 is pointing to, so after 3 all the node which was present after 3 would be same. So we will go to last iteration linked list. So after 3 we have 2. So after 3 2 will come. Now 2 is pointing to, you can see first diagram, 2 is pointing to 5. So 5, and after 5 all the node would be same, right? So after 5 actually we don't have any node. So this is the final linked list after iteration 2. Okay, so if you observe here carefully, we wanted to reverse this part of linked list starting from index 1 to index 3. So after completion of 2 iteration, in this case, this is how our linked list will look like. And if you observe this, at index 1 we have value 4, at index 2 we have value 3, and at index 3 we have value 2, which is in reverse order. Okay, now at the end what we will do, we will point this head to first node of this linked list. And what is first node of linked list? Dummy dot next. So dummy is 0 and next is node with value 1. So head will now point to value 1. Okay, so this is the complete linked list after reversing. So I hope now you have got some idea. Now let us check whether our method is working fine or not. So what I will do, I will create instance of this class with value 1. So node with value 1 is created, and now I will append these 4 nodes, 2, 3, 4 and 5. So this will create same linked list what we discussed to understand this method, right? Now let me do print value. So it will print all the nodes available in this linked list. Now I will run this. We have exactly same linked list. So now I will reverse this part what we discussed just now. So this is at index 1 and this is at index 3. So I will call reverse between method, and start index would be 1 and index would be 3, and after reversal I will again print the values of linked list. And let me print here before, and then we will call this method, and again we will print values. So I'll put after reversal. Okay, so you can see here before reversal value was 1 2 3 4 5, and after reversal value become 1, and then this part is reversed and this is same. Okay, So this final linked list will exactly look like this. So if you start with this first node, 1, 4, 3, 2, and 5. And this is also in same sequence, 1, 4, 3, 2, 5. Okay. So yeah, we have solved this problem. This was the exact requirement. And we have finally got the reversal of sublist of a linked list. Okay. So I understand if you have any confusion. So go through it 2 or 3 times and try to link this every line of this code with what I have explained using that slide. Okay. You can imagine better picture of it. Okay.